In this video, I will discuss the concept of Riemann sum and definite integral. The concept of definite integral is derived from the Riemann sum. So if you look to the right, for the Riemann sum, so I have a function f of x, I have the graph, and I'm saying that the function is defined. I'm only interested in the domain where x is between a and b. So I have a green curve, and then I would like to divide this domain into 5 subintervals. So that means I am using 5 rectangles to approximate the area under the curve from A to B. And then the method that I use is called midpoint. So you can see that from A to B, I divide that into 5 rectangles, right? So on top of each rectangle, I use the midpoint rule because I have a point right in the middle of each subinterval, right? I extend a line to the left, extend a line to the right, and then I line up to the bottom, so we get a rectangle. All right, so this is the midpoint rule. We are not trying to discuss midpoint rule right here. So if you try to read any textbook, they will use a symbol called x subscript I, and then they put a star in it. So do you see right here? They have a xi, and then they put a star. So what that means is the xi is any midpoint. Okay, any midpoint between A and B. And then the delta x is the width of each rectangle. So how do we find the Riemann sum? So you have to use a summation symbol. So this symbol right here, this symbol is a Greek letter, is called sigma. So when you see this symbol in mathematics, that means sum. Mathematics and statistics. So sigma means sum. Sum means you are adding stuff up. So we have the sum. I goes from 1 to n. So do you see that below the sigma, we have a I equals to 1 to n. So what that means is, let's do a little example right here. So let's say I have I goes from 1 to 5. I have xi. So what that means is I have x1 plus x2 plus x3 plus x4 plus x5. So it's adding up a bunch of terms. So x1 plus x5, I have to start at 1 and then terminate at 5. Okay, so this one I goes from I to n because I'm extending this to n subintervals. So fxi star, what is fxi star? Fxi star helps you to determine the height. So this one is the height. Again, the xi star, the star means any x value between the lower limit and upper limit of the domain. And then the delta x is the base. And then this is the height times width, or you can say the height times the base. Approximation contains under or overestimation. So regarding the matter of underestimate or overestimate in this type of problem, that is hard to tell because in each rectangle, you have some underestimation or some overestimation. So in this type of problem, I usually don't ask students whether that is underestimate or overestimate because that is hard to tell. Because if you look at any of the bars, like the one in the middle, there are some underestimation and some overestimation. All right, so that is the Riemann sum method. So again, the Riemann sum method gives you an estimation or approximation because when you look at when you do bars like that, bars or rectangle, you have some underestimation or some overestimation. So the answer is not accurate, too accurate compared to definite integral. So what about definite integral? The definite integral, so when you hear the word integral, that is the entire purpose of learning integral calculus. So let's take a look at the integral. So for the definite integral, do you see that I have the same graph? The function is defined between a and b. So what is definite integral? Definite integral means I am going to do the integration to find the area under the curve. So for the Riemann sum is only an approximation because there are some underestimation and some overestimation. So overall, when you find the answer, what the sum of all the areas of the rectangles, that is only approximation. But when you do definite integral, you don't need to draw rectangles anymore. So the result of the definite integral is the area under the curve. That is not an approximation. So what is definite integral? So definite integral, so look at this line. So that line is the integral. The way we read this is the integral of f of x dx. X goes from a to b. So the lower limit is x equals to a, the upper limit is equals to b. Look at the integral and the picture. The lower limit is x equals to a, the upper limit is x equals to b, and then the f of x is the function, the dx tells me that x is the independent variable. Just like in derivative, you know that like f of x equals to x squared, when you take the derivative, you have to know that the x is the independent variable. So the derivative of x squared is 2x. So that is the derivative of x squared with respect to x. You have to tell me which letter is the independent variable. When you do integral, the dx tells me x is the independent variable in this integral. So the integration sign looks like an S, but stretch a little bit, so that is called the integration sign. And then the f of x is called integrand. And then the dx tells you the independent variable is x, and then a is the upper limit, b is the lower limit. The result is a number, is a real number that tells you the area under the curve of the f of the function where x goes from a to b. So Riemann sum approximation, because you are using rectangles to estimate the area, it contains overestimation and underestimation. But for the definite integral, that is an exact value. So after you study the integral, we are no longer using the rectangle, the Riemann sum method to calculate the area. We will use integral to calculate the area. Alright, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel for me, share the video. I'll appreciate your help and support. As always, I see you all in the next one. Signing out for now.